Just before I start, I want to let you know that I'm using Jupyter Notebook. It works like a command line interface, but the difference is that you can run and rerun code blocks. So for this reason and many other reasons, I find it really easy to give tutorials using Jupyter. But this code we're going to make would work on any IDE or code editor. Okay, so let's start. So the topic is, what is machine learning? And we're going to do a very basic example. The intended audience for this is software or our software developers that want to figure out how to get started with machine learning. So what is machine learning? Machine learning is when a machine tries to learn using trial and error. And the best way to understand this is to see an example. So say we have some data, housing data, and we have the number of rooms in that house, and then we have a price. And so for example, this is one room house, so we have price of $500 per month, and this is the rental price per month based on rooms, based on number of rooms. Okay, and then we have another house, and then they told us that it has 2 rooms, and for that 2-room house the price would be 1,000. And then we have another one, and the rooms for that house is 3, and the price they said is $1,500 per month. And then finally we have another data, it's a 4-room house, and the price for that is $2,000. Now, obviously this is fictional data, but for the sake of this tutorial, let's pretend that this is the data that was given to us. Now let's say we've been given a challenge. You as a developer are tasked to make a function that, given a number of rooms, it returns or predicts the monthly rental price. So if you're given 1 room, you should predict 500, and if you're given 2 rooms, you should predict 1,000. And if you were given 5 rooms, which is not in our data, okay, then you should still be able to predict what the price of a 5-room or 6-room or 7-room house would be. Okay, so that is a challenge. Good luck. So if I would approach this, first I would make a function that says predict house price. It takes a parameter, number of rooms, and then it returns the price. But what is the price? Now if we look at our data here, we are able to spot a very, very obvious pattern. It seems that the algorithm here should simply be number of rooms times 500. And that is the function. Okay, so let's do that. And now let's test it. Okay. Predict house price. 1 room, 500. Perfect. Okay. 2, 1,000. 3, 1,500. Okay. And then 4, 2,000. Perfect. Now let's try 5. It predicts something. 2,500 would most likely be what the price would be for a house that has 5 rooms based on our data, and 6, 3,000, and so on. So yay, it works. But obviously, this is fictional data. And realistic data would be a little bit more different. More realistic data would probably look something like this. So let's change 500 to 550, for example. Let's change 1,000 to 900. Let's change 1,500 to 1,600. And let's change 2,000 to 2,100. This is still fictional data in the sense that we made it up, but it is closer to reality in the sense that it doesn't have a defined pattern. The pattern is not so obvious anymore. So given this change in data, our function here won't work as well now. The challenge to predict the house price is now a little bit more tricky. 500 might no longer be the best multiplier or modifier, and we need to figure out what the right one is. But how do we figure out what the right one is? Now what if we can replace this with modifier, and let's put here modifier, okay, and then we say predict house price 1, and we put 500 here. Let me put it back. Oh, it takes 1. Let me rerun this one. Okay, there. There you go, 500. What if we could try every possible modifier here, okay? Every reasonable modifier and figure out what the right one is. Or at least what modifier returns the closest to the right answer based on our data. So let's do that. Let me replace this. So let's create a loop for modifier, or let's just say for possible modifier in range from 0 to 10,000. Okay, and then we will say let's also loop for every housing data that we have for house in housing data, and then we say predicted house price is equals to predict house price, and then we pass it the rooms. Okay, so it will do 1, 2, 3, 4, and then we will give it the possible modifier over here. So it will try out. Now we will also need the actual house price, which is simply is the house price. Okay, now we need to find out what if it was close to the truth or not. So we'll call it distance from truth equals to the predicted house price, which is this one, okay, minus the actual house price. So the closer the better. Just so that this is never a negative value, we will make this absolute, okay, so that we always get a positive difference. And then we want to get we want to store the possible modifier that has the smallest or the closest distance from truth. So we say best distance from truth, okay, or let's just call it smallest distance from truth is great. So if distance from truth is less than the smallest distance from truth, then we will save the best modifier. Best modifier equals to the current possible modifier, and the smallest distance from truth is now the distance from truth that we have right now. Okay, let's instantiate these so we have them. We have the best modifier, we'll start out with 0, and then the smallest distance from truth, because we'll just initiate it to a really big number, so it immediately gets replaced. All right, and then, okay, all right. So we will then take note of the best modifier, and we take note of the smallest distance from truth. We replaced it so that it can be replaced only by the best one. And finally, when we're done, we just print the best modifier so that we find out what it is. Let's run. And voila! The computer, using magic trial and error for every single one, discovered that the best modifier is 450 based on this formula, this on our predicted house price. Okay, so let's test it out. So predict house price 1, and then say 450, just this one, and it's 450, which is off by 100. And if we do 2, it's 900, which is on the mark. And if we do 3, it's 1350, which is off by around 250. And then finally we do 4, and it's off by just about 200. So we now have the best modifier according to our trial and error. And that's it. That is really the core concept of machine learning. Machine learning has 4 components. You have this one, the prediction model. This is called, in machine learning, this is also called the model that's used to predict. And then you have the variables for the computer to determine using trial and error. We call it modifier here. But in machine learning terminology, these are what you call weights and biases. Now this can be more than one variable, but for here we call it modifier. You have a training loop here, and it tries out different possible values for the modifier. And finally, you have a distance from truth formula that you use to let the computer decide or learn which variable it should keep And so this is your distance. So the smaller the distance from a truth variable is, the smaller the result is, the better the computer thinks it's doing, and it will store those modifier that it's trying out to its best modifier. So that's really what it is. In machine learning terminology, distance from truth is also called cost. A modifier is called weights and biases. And this is called the training loop, the training step. One step is of the loop is a training step. And then finally, this is what you call the model to predict. So that's it. Let me just undo these so our functions still work. Okay, one more modifier. Okay, perfect. Okay, now in more sophisticated machine learning or more practical use cases of machine learning, you really don't only have a single variable or modifier. For example, in our housing data, in reality, you don't only have the number of rooms as the only predictor of price. Here, rooms and price. You have more than that. So for example, I have here another data that is slightly more realistic. So for example, over here, this would be a more realistic housing data. Still fictional, but more realistic in terms of structure. So you have rooms, you have the number of square feet, you have the number of the distance from city, you have the age of the house, like how old the house is. These are all factors or contributors to the price. So you have three variables, one, two, three, four variables instead of just one. Okay, so now you have to also modify your model. So instead of having a model like this, our model would probably look something like this. Spaces here. Okay, so predict house price 2 would take in the number of rooms, it would take in the number of square feet, the distance from city, and the age. And then the computer would try out different modifiers, one for the room, one for square feet, one for age, and one for distance. So then our room score, for example, would be the number of rooms times the room modifier, which is very similar to this. Okay. And then we have a size score, which is the square feet or the area score. And then we have the distance score, which is distance from city times the distance modifier that the computer will try. And then age score, which is the age or how the house is times the age modifier. And then you would do something like the price would be the room score plus the size score minus the distance score, because the farther away from the city it is, the lower the price is, usually like that. And the older it is, or the bigger this is, the less the price should be. And then that would be your new model for predicting the price based on this new data structure that you have. And also this would affect our training step. So instead of a very simple and you're only looking for one possible modifier, you would have something that looks more like this. So let me paste that. Okay, so now you would have to look for a possible room modifier, you have to look for a possible square feet modifier, possible age modifier, possible distance modifier, and then you would loop that to get but this part would just be the same. You just try out your model. So you call in your model, predict house price 2, and then you'd get your predicted price, and then you're going to compare it again with your actual price to get your distance from truth or your cost. And when you do that, you still have to compare if it's better than the previous step or the previous best. And then when you do is you save or you store the best modifiers that created the best or the smallest distance from truth. Okay, so obviously this gets more complicated, but the principle remains the same. Machine learning, let me just type it out. Okay, let me type it out the very last so you remember it. So here, machine learning is simply the computer using trial and error to find the best values for defined variables that gives the result closest to the truth based on given data. So it uses trial and error in the training loop. Here you go. and then it finds the best values by finding out the distance from truth, and then it stores the best values, the best modifiers for defined variables, which is the modifiers, that gives the result closest to the truth based on your distance formula or your cost formula based on the given data. So based on the data that you have been given. And that's really it. And on the next tutorial, we're going to discuss how the TensorFlow or other machine learning frameworks make it easier to set up calculations like this. Because what if you have more than just 5 modifiers, 1, 2, 3, 4, if more than 4 modifiers, this actually is already going to take long. So if you have it, we're going to discuss how frameworks like TensorFlow make doing something like this with 4 variables up to millions of variables very easy or convenient for the programmer. So that's it, and I would just like to end with thank you.